Okay, so we are now looking at shop floor planning and job sequencing. And this evening, we are looking at Johnson's rule and the Gantt chart. Johnson's rule and the Gantt chart. All right. So under this one, we're looking at question 4. Now, Johnson's rule states that, let me just give a statement for Johnson's rule. Okay, so Johnson's rule is a very, very important aspect So Johnson's rule. So Johnson's rule states that if the shortest processing time for the job is in work center 1 or machine 1, do that job best in the shed. But if the shortest processing time is in work center 2, but if the shortest processing time is in work center 2 or machine 2, do that job last in the shed. All right, so what am I trying to say? What I'm trying to say is that when you're looking at this problem here, question 4 says a Lusaka-based printing company has invested in printing press in order to ensure a steady flow of printing jobs. The company has managed to secure printing service contracts with a number of learning institutions in the country. So if a business appears to be thriving, most learning institutions have no printing facilities to most of their learning and examination documents required. The operation manager at the company is scheduling the following set of 7 jobs as shown in the table below to be processed through its press machine and then binding machine. Processing time at each of these work centers is as shown in the table. What is the optimal sequence for these jobs to be scheduled? How long will it take to complete all the 7 jobs based on their optimal solution? Use a Gantt chart to show the durations. So this is where this 15 marks is ending. Now, this can be done somewhere this side. Let's see where we can do. We need to okay. So we have the printing hours. There's also the binding hours. We have 15, 7, 4, 7, 10, 4, 7, 3, 9, 10, 6, 9, 5, 8. So under this one, we have the job is A, B, C, D, E, F, G. Okay. So you cannot, one cannot bind something he hasn't printed. So the binding comes second. So you have the printing and we have also the binding. Okay. So we have 15, 7, 4, 7, 10, 4 and 7, 3, 9, 10, 6, 9, 5 and 8. Okay. Yeah. So now the using the Johnson's rule that states where it says Johnson's rule states that if the shortest processing time for a job is in work center 1 or machine 1, do that job first in the schedule. But if it's in the work center 2, machine 2, do that job last in the schedule. So the overall, the sequence here is going to be in this way. The smallest time that we have here for all the times is a 3. So 3 is in binding. Overall time is 3. So 3 is in binding. So we do job A last, according to the Johnson's rule. So short processing time, if it is in A, you do it first. If it's in B, you do it last. So we do the binding last because 3 is at is in binding. So what is going to happen? This job will be done last. So job A will be done last. The remaining times for these jobs, the smallest possible time for these jobs is actually 4, but of course there are 2 of them. So there's a debate on which one to start with between job C and job F. So what is going to happen is that we look at the one which has a shorter time, the other side, which side in the other department in binding. So we'll start with F, because F was the shorter time binding. So F has 4, so this one will be worked on. I'm canceling because we don't want to duplicate. The smaller time remaining is 4. So 4 is in printing, you do the job first. So C follows F. So this one goes. Then the other time remaining for the remaining processing times that are remaining, it is 6. 6 is in binding, so it should be done at last. This is D, because it is in binding. So this one goes. Then the other one here, the remaining time is actually 7. So we can see we look at the one which has a shorter time. The other side that we can start with is G. So G there. So G is being worked on. Then the remaining time for these ones is 7, which is in 1, which is printing, which should be there B. And then the last one remaining is just last one which I'm talking about is E. Okay, so E is the one remaining. So this is how the job sequence comes. So the optimal sequence is F, C, G, B, E, D, and A. So this is the optimal sequence for the jobs. So now after this, we need to do a Gantt chart. All right. So F, okay. So we found FCG, FCGBEDA. All right. So after getting this one, we need to do a Gantt chart. Okay. So just a recap on this same one. Johnson rule states that if the shortest processing time for the job is in printing, do that job first in the schedule. But if it's in binding, do that job last in the schedule. So the first one we looked at was A, which was at last, because it has a 3. Okay, so A has a 3. So we did it at last. Okay. Then the building up, because if the sequence is wrong, it will just actually affect the other things that we are doing. Okay. So this one, the first job, this one, job 3 is in binding, so it should be done last. All right, then, so A, even from here, we can start. We can do job A at last. The remaining time here, we said it is 4 is the remaining time, shortest time. So you start with FY because it has a shorter time in this other department between the two. Then you're going to go for C. So this one, so we go for C now. Okay, it has also 4. Then the smaller one to go for is what? It is a D. Okay, it is a, the remaining time is a D, which has what? A 6. So a D has a 6, meaning that it should be done at last. D as a 6, so D should be done at last because it's in binding. So D should be done last because it is what? In binding, which is this one. This one, this one, these ones are done. So D should be done last because it's in binding. Then, okay, so it's done in binding. That one is being worked on. Then the other one to work on is between B and the G for the remaining times is G, but should be done earlier than B. Okay, so G should be done earlier than B. Okay, because it has a shorter time in the other what? In the other G has a shorter time here. So we done it earlier. Then B comes in. Okay, so B comes in. Then the remaining one is just E. So this is a job sequence. Job sequence. So this sequence that we have, we can now do the Gantt chart. So for the Gantt chart, okay, what is going to happen here for the Gantt chart is that we have the printing, and we have what? The binding. So what it means here is that we are following the sequence, okay? The sequence we are following is the F, C, G, B, E, D, and A. So the first job to start working on is job F. So when you are doing job, you are printing this job, there's no way you can be binding it at the same time. So you wait until it's being printed. That's when you can start binding it. So meaning that that F is taking 4 hours. Okay. Now that it has been printed, they can start binding it in the other department. So when they're binding it in the other department, this F is taking how many? F is taking 5 hours. So what is going on? Okay. So you may start this so that people will understand thoroughly on this one. Quickly, we'll be finishing in the next 5 minutes. So under this Gantt chart, we are simply saying we have these two aspects, the printing and the binding. So this job F, we're working on it here, is taking 4 hours, but here there is idle time because it's the same job that they needs to wait until they finish printing. That's when they can start binding it. Now they can start binding it. Binding it is 5 hours. So what is happening by the time they're finishing binding? We are looking at a sequence which is F, C, G, B, E, D, and A. So we are getting the data from this table here. Okay. So getting the data from this table. So we're simply saying that by the time they're finishing, they have printed already. Here, they can't start binding it. That's why we have idle time here for now, because they are waiting for the same job to be printed. Now that I've printed it, they can start binding it in the other department. Binding it is taking 5 hours from the table here that we have. Okay, from the table, this one taking 5 hours. All right, so by the time they're finishing binding F, the guys in printing would have started working on C because it's a different job. So C there is taking 4, which means you can do, you can see C is taking 4 in printing. So meaning that here we still have a 1 hour more that the guys are taking to finish binding this. So meaning that in the first department, They have nothing to wait. They can start working on job G. Job G there. So job G is taking, job G is taking 7 hours for printing. So meaning it's actually taking how many hours longer from this point? It's taking 6 hours. All right. So what is going on in the department of binding? Since they finished printing F and they finished binding it, so now they can finish. The job should be completed from printing to binding. So they can start working on C. C in binding is taking 10. So here C is taking 10. So it would have taken 4 hours longer. So by the time they're finishing binding, by the time they're finishing binding C, meaning that they're taking a little bit longer. And the guys in printing, the people in printing would have finished printing G, immediately finishing printing G. By the time they are finishing binding C, the people would have finished printing G and would have switched on to job B. Job B is taking 7. So B is taking 7. So here is just a matter of addition and subtraction. So this one is taking how many hours longer? 3. So what happens is by the time they're finishing printing B, the people in binding would have started binding G, because F is fully completed, C is fully completed. So G, your binding is taking 8. All right. So G is taking 8, meaning that here it would have taken 5 hours longer. By the time they're finishing binding G in printing, they will start printing E. E is taking 10. So E is taking 10, meaning E would have taken 5 hours longer. By the time they're finishing printing E, G has been fully completed. So B should also be taken for binding. B for binding is taking 9. So B for binding is taking 9, meaning that it's taking 4 hours longer. By the time they're finishing binding B, meaning that the department for printing, they were started working on D. D is taking 7. So D is taking 7. So meaning that it would have taken 3 hours longer. By the time they're finishing printing D, the people in the department for binding, they would have started binding E. Binding E is taking 9. So meaning that this would have taken 6 hours longer. By the time they're finishing binding E, the people in the department for printing would have started printing A, sorry. So A is taking 15. So A is taking 15, meaning that this is taking about 9 hours longer. So now the people in the department for printing, can even relax. They can say, okay, they have done what they need to do. They have done their printing, they have finished the printing. So they are just waiting for people for binding to finish their job. So this, what it means is that the people in binding, they have finished binding E, they have finished binding B, they have finished binding C, they have finished binding. So meaning they are yet to finish binding D. Binding D is taking 6. Okay, so binding D is taking 6 there. So meaning that is 9. So D is taking 6. Okay, so meaning there's this time here, which is 3. This is 3. It means that they should wait for A to be completed being printed, because A is ending here. So this is the time because they need to wait for them to finish printing A. It's not, they can't start binding it at the same time. So this is an idle time for guys in binding. So we have this idle time. It's a time that they should wait for A to be fully complete. So now they can start binding A, meaning that by the time they're binding A, the guys for printing would have finished printing everything. So A being binding, A is 3. So the total time required now. This question says, what's the total time required? Here it was asking us to find the total time required. Okay, what is the total? How long will it take to complete all the 7 jobs? So total time required, we simply just have to add now total. Okay, so this is the only tough point for shop floor planning, because it requires addition and subtraction here. So we are just adding all the time. So you can either use the topmost aspect there, or the bottom, or the time taken for the people who are in binding and printing. They should wait for each other before they knock off. So you add all the times there. So we are adding 4 plus 4 plus 7 plus 7 plus 10 plus 7, then plus 15, then plus the time that they are also idle, which is 3, because they are idle here, because they are waiting for the people in binding for them to knock off. So the time taken, we can either use the total time for, this is for printing, or the total time for binding should actually give us the same value. So this is the 8 plus 14 plus 10 plus 7 plus 15 plus 3. Their time was 57. Okay, so that's the answer. So if we always use the total time for binding, we can simply just quickly add. So the total time for binding should be the same. If you find different answers, then there will be a mistake somewhere. So it says it's a 4. There is a 4 here, which is for idle. I started counting because they have come for work already. They are at work. Plus the 5, plus the 10, plus the 8, plus the 9, plus the 9, plus the 3 for idle. Again, plus the 3. So this is giving us 4 plus 5, plus 10, plus 8, plus 9, plus 9, plus 6. Okay, 4 plus 5. Oh, there's a 6 there, sorry. There's a 6. Omitted the 6. This one, I omitted it. Should add it, not here. Plus a 6. Okay, so 4 plus 5 plus 10 plus 8 plus 9 plus 9 plus 6 plus 6. So the answer is 57. So the total time required is actually supposed to be the same. So 57 hours. So this is the Johnson's rule and the Gantt chart. So just a matter of going through the recordings and seeing what happens on this one, please.